Hello everyone, section 10.4, inscribed angles and polygons. Example 1, find the indicated measure. So the first thing we want to find is the measure of arc DG. Arc DG is here. We know from our inscribed angles theorem that the inscribed angle is half the measure of the arc. So arc DG has to be 80 degrees. Measure of angle G is here. Angle G is intercepting arc EF, so angle G is half of 58. So angle G is 29 degrees. Example 2. Find the measure of angle HM of arc HML. So HML is here. The angle that intercepts that is 109 degrees. So HML, measure of arc HML, is twice 109, or 218 degrees. Now we want to find the measure of angle HJK. HJK is here. So measure of angle HJK. HJK also intercepts arc HML, so it's got to be half of arc HML, so 109 degrees. What do we notice about the angle HJL and LKH? They're the same measure, therefore they are congruent. Angle HJL is congruent to angle LKH. Sorry. HJL. There. This leads us into why the inscribed angles theorem is what it is. All right. Given that angle C is 68 degrees, find the measure of angle B. Measure of angle B must also be 68 degrees because they both intercept the exact same arc AD. Okay. One of my favorite theorems in the book. One way that ancient Greeks used to make right angles is you inscribe any angle in a semicircle and it has to be a right angle because it's intercepting a 180 degree arc. Since it's inscribed, it's half of that 180 degrees, so it's 90 degrees. So 5x equals 90 degrees. X is equal to 18. Just 18, sorry. X is equal to 18. Okay, that's part A. Part B. So if we inscribe a quadrilateral inside of a circle, then the opposite angles have to be supplementary. Why? Well, this angle, and this is the inscribed quadrilaterals theorem, this angle intercepts arc ABC, and this angle that's opposite it intercepts arc ADC. If you add angle ABC to arc ABC to arc ADC, you get 360 degrees. These angles are half of each of those arcs. Half of 360 degrees is 180 degrees, making these two angles supplementary, these two angles supplementary. So opposite angles of a quadrilateral are supplementary, which leads us to 3a plus 111 equals 180 degrees, and b plus 65 equals 180 degrees. Solve each of these. Let's subtract 111 from both sides. 3a equals 69 divided by 3a is equal to 23 degrees. And b subtract 65, b is equal to 115 degrees. And we have instructions for how to construct a square inscribed inside of a circle. Follow my video on that. I think it's construction number 21 or 22. Example 5, your camera has a 90-degree field of vision. That means when you look out, the angle at the edges of the field of view is a 90-degree angle. You want to photograph the front of a statue. You stand at a location in which the front of the statue is all that appears in your camera's field of vision as shown. Now it's shown on the next page. I'll flip to that in a second. Explain how to find locations where the right side of the statue is all that is seen in your camera's field of vision. So here's what we're talking about. And I chose the Statue of Liberty as a statue that you want to take a picture of, and you stand so that your camera sees at the edges this corner and this corner. In other words, what's out here, the camera can't see that. Okay, it's not caught in the lens of the camera. It's only catching the base of the statue. Well, where does that occur? That's going to occur because that's a right angle on this semicircle, which has a diameter of the face of the statue that you want to take the picture of. And that's because these are all right angles, and any angle inscribed in a semicircle is a right angle. Okay? As a side note, I took this picture while on a field trip with Mr. Scully. Example 6. Find the values of x and y. So the value of x, angle x, is going to be half of the intercepted arc DEF. Arc DEF is 150 degrees. So x is equal to 75 degrees. Y is going to be half of EFG. We're not sure what EFG's value is, but because we don't know FG, we can figure out FG pretty easily because we know all the rest. So 360, let me hold my calculator. 360 minus 90 minus 80 minus 70 gives us 120 degrees. So this y is 120 plus 70, which is 190 divided by 2. Y is equal to 95 degrees. Example 7. Arc segment RS and segment TU are diameters. So we have two different diameters. They're both going through the center here of circle A. Line RB is tangent to circle A at point R. Find the measure of angle BRT. Okay, so angle BRT, according to the tangent intersected chord theorem, at the bottom here, tangent intersected chord theorem, is half of the arc that it intercepts. So what arc is angle BRT intercepting? It's intercepting arc RT. Arc RT is equal to the central angle, TAR. What's the measure of angle TAR? 180 minus 126. 180 minus 126 is 54. So the measure of arc RT is equal to 54 degrees. The measure of angle BRT is half of that, or 27 degrees. All right, angle TRS. Angle TRS is an inscribed angle, and it's half of arc TS. We just figured out, so arc TS is 125 degrees. Central angle, 126 degrees. Sorry about that. 126, vertical angle 126, central angles equal to the arc, 126 degrees. Angle RTS, so measure of arc TS is equal to 126 degrees. And the measure of angle RTS is half of that, or 63 degrees. Example 8, find the following values. Okay. Measure of arc DC. Arc DC is here. DC is twice 32, or 64 degrees. Arc BD. BD is over here. BD is what's the remaining part of the semicircle. BD plus DC equals 180. DC is 64. So 180 minus 64, 116 degrees. So the measure of angle BCD. BCD, right here, intercepts arc BD, half of arc BD, 116 divided by 2, 58 degrees. Or we could have said that has to be a right angle. 32 plus what has to be 90. 32 plus 58 has to be 90. Two different ways of coming up with the exact same answer. Angle BDC we know is 90. Angle ABC. Angle ABC up here. Angle ABC is a tangent and a diameter. So it has to be a right angle. Angle ADB. So angle ADB right here. Angle ADB has to be half of arc BD, so 58 degrees. Congruent to angle BCD up here. That's example 8. Example 9. Find the following values. UY is tangent to the circle at point V. We have a couple congruents, and we've got 70 degrees here. Okay, so find the measure of arc VW. VW is here. It's twice the 70 degrees. It's 140 degrees. Find the measure of angle W. Okay, well, if this is 70 and this is isosceles, then there's 110 divided by 2 to give me here and here. So 55 and 55. So 55 degrees. Measure of arc Vx, twice the 55, 110 degrees. Measure of angle UVX. So UVX here is half of this arc, which we just found. Just found the measure of arc Vx to be 110. So angle UVX is 55 degrees. Measure of angle YVW. So YVW is going to be half of arc VW, which is 140 or 70 degrees. Example 10. O is the center of the circle. Name an angle whose measure is equal to the measure of the given angle. Okay, so we have angle ADC. ADC is inscribed in the semicircle, this semicircle. Angle ABC is inscribed in this semicircle. So they are congruent. It's congruent to angle ABC. Angle CD to B, it's not drawn in here. CTB is the same as angle BAC or CAB. They both intercept arc BC. So congruent to angle BAC. Angle ABD is this one here. And that's congruent because it intercepts this arc. It's congruent to angle ACD. Angle ACD. And angle ADB. Angle ADB, this one here, intercepts this arc AB. So that's angle ACB also intercepts arc AB. So angle ACB. Example 11. Example 11 I did some work on before I started the video. Quadrilateral FGH is inscribed in a circle. Give a numerical answer. So the measure of angle F is equal to x squared. The measure of angle G is equal to 9x minus 2. The measure of angle H is equal to 11x. And the measure of angle J is equal to x squared plus 20. There are three different equations that you can come up with that's going to give you the correct value of x, which will then lead you to find the measure of the largest angle. So what are the three different equations? So angle F and angle H are opposite angles. Angle G and angle J are opposite angles. So angle F and angle H have to be supplementary. So x squared plus 11x has to equal 180 degrees. Angle G and angle J have to be supplementary. So x squared plus 20 plus 9x minus 2 has to equal 180 degrees. And the third equation is all four of these angles have to add up to 360 degrees because it's still a quadrilateral, and adding up all four angles of any quadrilateral is going to add up to 360 degrees. So x squared plus x squared plus 20 plus 9x minus 2 plus 11x has to equal 360 degrees. So I solved each of these. Set them equal to 0. X squared plus 11x minus 180 equals 0. X squared plus 9x minus 162 equals 0. And this last one, you're going to get 2x squared. Eventually, everything's going to divide by 2. I'm going to jump right down to the x squared plus 10x minus 171 equals 0. So all of these factor. They're all factorable. First one factors x minus 9x plus 20 equals 0. The second one factors into x minus 9 x plus 18 equals 0. And the last one factors into x minus 9 x plus 19 equals 0. So in all three cases, we get x equals 9, or x equals a negative number here, negative 20, negative 18, or negative 19. The negatives don't apply in our problem because we're dealing with actual angle measures. So the angle measures can't be negative, right? We couldn't put a negative in here. We could have put a negative in here and get an actual answer. We could put a negative in here and get an answer, and they would work. But if I put a negative in here, then I'm going to get a negative valued angle, and that's not going to work. So the negative ones don't work. The x equals 9 is the only one that is correct and does work. So if x is 9, then the measure of angle F is equal to 81 degrees. Measure of angle G is equal to 79 degrees. The measure of angle H is equal to 99 degrees. And the last one, measure of angle J, is equal to 101 degrees. And that is the largest angle of the group. Okay, so of all of these, 101 degrees is the only one, or is the final answer to the question. Example 12. The diagram shows a regular polygon with 7 sides. So because it's regular, all of these sides are congruent. All of the interior angles are all congruent. This angle is not congruent to this angle, though. This is not an interior angle, and this one's not an interior angle. We've got diagonals breaking them up, okay? But if we inscribe this polygon inside of a circle, okay, then, so if this was all inscribed inside of a circle, then this arc is going to be congruent to this arc, and I'm just trying to sketch it, and this arc, and this arc, okay? All of these arcs are congruent because all of the segments are congruent. Congruent chords, congruent arcs, right? In the same circle. So congruent chords, congruent arcs. Since the arcs are congruent, and each of these angles are half of the arcs, each of these angles are half of congruent arcs, then each angle is congruent. So because angles 1, 2, 3, 4, and 5 are half of the same valued arcs, half of the same congruent arcs, then they are all congruent. Okay. Will your reasoning apply to a regular polygon of any number sides? Absolutely. Has absolutely nothing to do with the fact that this had 7 sides. The fact that this was 5 angles was irrelevant. It doesn't matter. We could have a decagon, a dodecagon, a 20-sided figure. It wouldn't matter. These inscribed angles would all be congruent. That's the end. Thank you very much. Bye.